Integration by partial fractions case 1, distinct linear factors. Let's get started. So distinct linear factor, if you take a look at the denominator, we have y times y plus 2 times y minus 3. They are linear, they are distinct, they are all different, right? And they are linear. The y raised to the first power. So since this is linear, then we have to break this down into 3 smaller fractions. We have 3 factors, that's why we need 3 fractions, 1 for each factor. So the y goes to a, b, y plus 2 for b, and then the y minus 3 for c. And then if you ask me this again, is the order of a, b, c important? The answer is no. You can let y goes to b, y plus 2 goes to a, that's completely fine. So the order of a, b, c is not important. And then in the next line, for a, we have y, and then we need the other 2 factors for common denominator, right? So that's why we have to multiply the top and bottom by y plus 2 times y minus 3, y plus 2 times y minus 3. And then for the plus 2, we need a y and a minus 3. We need a y and a minus 3. And then for the minus 3, we need a y, and then we need a plus 2. Y and a plus 2. And then the next line, you want to take the y, multiply the factors. So this one we have y plus 2 and y minus 3, b times y and a y minus 3. Let's write that y again, y and then y minus 3, and then the c times y and y plus 2. And then we are going to what? We are going to fully expand this, but this line is very important. So why don't you just write this down, because I am going to need this line again. Okay, let's fully open up the a. So this, we have a times y squared minus y minus 6. And then this is b, y squared minus 3y. And then c times y squared plus 2. Plus 2y, not plus 2, plus 2y. Okay, and then we open up the a, b, and c. So we have not open up, we distribute the a, b, and c. Ay squared, ay, 6a, b, y squared minus 3by, and then plus cy squared plus 2cy. And then you group all the squares together, group all the first power together. So this one, if you want to skip a line, I can help you with that. Just underline all the square. Okay, so underline all the square, and then you use a different color to underline the first power. So this is the first. Maybe I should use a different color to give you a better contrast. The first power, the first power, and the first power. And then the last one is the minus 6a, right? Okay, so let's group them. So this one, you can just draw a parenthesis, and then write the a, and then the b, and then the c. Leave the y square outside. And then draw another parenthesis, leave the y outside. So this one we have a minus a and a minus 3b, and then a plus 2c. And then the last term is just a minus 6a. Okay, and then on the other side, I have 4y squared minus 7y minus 12. And then now we equate the coefficient. So let's use an arrow. So for the 4 is the coefficient of y squared, so 4 matches to the coefficients for the y squared on the other side. And then we have a negative 7, so let's use a different color. So negative 7, so negative 7 matches to this, the first power, right? And then the last but not least, we have a negative 12, so the negative 12 matches to the 6a. Okay, so write the equating the coefficient. I will write the words for you. So equate the coefficient. So what do we have? We have 4 equals to a plus b plus c, and then we have a negative 7 equals to negative a minus 3b plus 2c. And then last but not least, we have negative 12 equals to negative 6a. So obviously a is equals to 2. So that simplifies the system a lot. So a is equals to 2, and then we plug in a. So these two lines now becomes 4 is equals to 2 plus b plus c. Negative 7 is equals to negative 2 minus 3b plus 2c. And then we can simplify this one more time. And then now what do we have? 4 minus 2. And then negative 7 plus 2. Okay, so this is the system that we have. How do we solve for B and C? Okay, you can multiply the first equation. You can multiply the first equation by 2 on both sides and then subtract them. Another way to do this, you can put one in terms of another. I will just multiply top and bottom by the first equation. So the first equation, I will just multiply 4 on both sides. So 2 on both sides. So 2 times 2, and then 2 times B, and then 2 times C. Again, I multiply both sides by 2. And then the second one, do not touch that. So now subtract them. Negative 4 minus negative 5, that is 9. And then negative 2 minus minus 3. And then 2 minus 2 is 0. So we have B is equals to 9 over 5. So that is B. And then we should be able to get C very easily. All right, let's go ahead to get C. So we have 2 equals to B, 9 over 5 plus C. Then C is equals to 2 minus 9 over 5, right? And then the 2, we can change the 2 to 10 over 5. So 10 over 5. So C is equals to 1/5. All right, we got A, B, and C. So A, B, and C for what? A, B, and C for the 3 fractions in the very first line under the word distinct linear factor. So we have A, B, and C right here, right? So we have A, B, and C. We just got A, B, and C. Now you plug in A, B, and C in there. So we are doing integral, right? Integral. So we are doing integral A over Y. So that is 2 over Y dy plus integral B over Y plus 2. That is 9 over 5 divided by Y plus 2 dy. That is another ln. And then C, 1 over 5, and then Y, this is a Y minus 3 dy. Simple. So the answer is equal to 2 ln absolute value of Y plus 9 over 5, ln absolute value of Y plus 2, and then plus 1 over 5, ln absolute value of Y minus 3. The absolute value is not optional because you have to guarantee inside the absolute value, you have to guarantee the ln you get a positive, because ln 0 is undefined, ln negative is undefined, and then you plus C. So this is the final answer to the integral. And then this is not the end yet, so allow me to introduce another method other than solving a system. So how do you get the A, B, and C? How much work did you do? So we just went from here, right? So we starting at which line? We started at this line, and then we do all the algebra. So we do many lines, and then we solve a system to get the A, B, and C. Is there an easier way to get the A, B, and C without showing that much of work? The answer is yes, and it is absolutely worth it to learn this method. Trust me. So let me show you how easy it is. I am going to take a line. I'm going to take this line for my work. So I'm going to hit this. I'm going to copy and then paste. I'm going to paste this line over here. I'm going to paste this line. So what I am about to do next is a very convenient method to get the A, B, and C. Let me show you how easy it is. So look at the red factors. Y plus 2, Y minus 3, and a Y, right? So now, look. What if Y is equals to 0? So when Y is equals to 0, do we agree that the B is gone? The C is gone. B times 0 is gone. C times 0 is gone. So the 0 eliminates the B and C for you. So you only need to take care A. So on the left hand side, when you plug in the 0, 4 times 0 squared minus 7 times 0 minus 12 equals to A times 0 plus 2, 0 minus 3. So what is that equal to? That equals to negative 12 on the left hand side, and then negative 6A on the right hand side. So A is equals to 2. Look at how easy that is. No distribution, no system. I just got the A for you in a few lines. And then the next one, what if Y is equals to 3. So when Y is equals to 3, the A is gone and the B is gone. So you only have the C. So 4 times 3 square minus 7 times 3 minus 12 equals to, on the right hand side, no A, no B, because 3 minus 3 is 0. So you have C times 3, and then 3 plus 2 is equals to 5. So overall, this is 36 minus 21 minus 12 equals to 15C. So you have 3 equals to 15C, then C is equals to 1/5. No system, no distribution. You don't need to write many lines. And then the last one, let's take care of the last one. So the last one is, what if when y is equals to -2? So when y is equals to -2, this is gone, this is gone. So the A and the C, they are both gone. So you have 4 times -2 square minus 7 times -2 and then minus 12. That is equals to, you only keep the B, right? So that will be B times -2 and then times -2 minus 3. So on the left hand side you have 18. On the right hand side you have 10B, and then B is equals to 18 divided by 10. That is 9/5. So if you use this method, you can get the A, B, and C without doing any crazy algebra and solve any crazy system of linear equation. So here is another hint for you. Depending on the size of the problem, the system can be very big. I still remember the problem I got on my calculus exam. I got a big system. The system is so big, I only have 15 minutes to take the exam. I was unable to finish solving all the letters in the system. So I got partial credits for all the works I did, but I didn't get full credits because I was not able to finish the system. The test was only 15 minutes and I got many problems on the test. So this method should save you some time on the exam. So it is absolutely worth it to learn this method. This method might not work every single time, but when this method works, everything is super convenient. And then the equating the coefficient, the system method, that works every single time, but sometimes that takes a lot of work. Remember, when the problem is big, the function is long, let's say you have 5 these linear factors, the system can be huge, right? The system of this type of problem can be extremely big. Okay, so that is the end of this video. If you think my instruction is helpful, give me a like, share the video, let more people learn this from me. Appreciate for your help and support. See you all in the next one. Signing out for now.